Alright guys, today I'm going to go over Firestarter 32. Sorry it's a little late. My wife had to work today, so I was taking care of cricket babies. Now, I said the first thing I want to do is I want you to look up three properties of logarithmic functions online. The first one that I have here, so I'm not going to count this one as a property. It's more of a definition. They're saying this is how you go from logarithmic form to exponential form and vice versa. So it's not entirely a property. But I do have three properties for you that we'll probably use later in the week. So going forward, I will say what I did the easiest way, like I figured you guys would do the same thing, is I just looked up properties of logarithmic functions, and the first thing that came up is where I'm getting my information from. I also could have done it from the book too, but I wanted to have exactly what you guys have probably seen. So, logarithmic functions, remember, are based off exponential functions, and we had a property, we had a logarithm of a product, we have a logarithmic, or when we had exponential functions, we had product of powers, that means, so they're based off of exponents. So if you remember, so this is more like a recall, we had something that looked like this. Now, I didn't use these letters, this website used these letters, where you, if they were next to each other and the bases match, you add them. We had one that said if they were on top of each other and the bases match, then you would subtract the exponents. We also had one that said if they were a power to a power, then you would multiply the exponents. All three of these, with that definition, actually could be used to prove these properties. I'm not asking you to prove them, I just want you to write them down. So, there's going to be three properties that we're going to use. The first one we're going to talk about is going to be the logarithm of a product. So that we're going to call it the log of a product. So, the logarithm of the product, pretty simple to state. It says if you have a log, remember this little subscript that's a b, it's for the base, and you have two things being multiplied, you can split that up into the log of bm, and then you're going to add it to the log of bn. So that's important that we do that. Alright, so that's the log of a product. Alright, so now the next thing we're going to have is called a log of a quotient. Alright, this is important. So basically it says if I have a base, I can split it into subtraction. That's how you... Alright, that's good. And there's sometimes that might be helpful. That'd be helpful if we had like sometimes there might be a way to split this using the bases match and things like that. So let's say I could make an example, and I'll probably do an example at the end of all three of these. So the next thing that we have a log of a power. The last property I'm going to talk about is the log of a power. So that one says if I have a log and it's m to the nth. Now remember, if you were like, that's going to actually be inside the parentheses. It's a little bit different if it was the log is being done first. So that usually they don't write that set of parentheses there, but technically I guess it would be implied. So that says you move that little n out front. So that's good. The other thing that we'll probably talk about next is like if I have a to the m and I say it's equal to a to the n, right? If these bases match, I can then therefore say this, m has to equal n, and we'll use that in the next slide. But that's not really a logarithm property, that's more of an exponent property, but it is something that kind of makes the exponents go away, so sometimes we talk about it now. Alright, so we got three of them. Number 2, look, I noticed that these match, so all I do is I say x plus 3 equals 6. Now I'm going to minus 3 from both sides, so I get x equals 3. You do want to plug that in to make sure that it is going to still work. Sometimes there are some weird things that happen, especially if I make those equations complicated. But in this case, I am not going to do that, so it does work. Right. Now, with 3 and 4, I'm just going to use this definition. So that's all I'm going to do is use the definition. So there, that is my b, that is, actually we're going to call that y, so I guess I'm being kind of confusing, and we'll call that x. All right, so b5 squared equals x. Well, 5 squared is 25, so x equals 25. All right. 4, I have, this is my b, so I have 3. This is the exponent. So I have 3 to the 4th equals x. 3 to the 4th is 81, so x equals 81. That's it. Those are probably the most simple logarithmic functions we have, and all it is use this definition. So look, I have it in log. I don't know how to get x by itself, so all I do is I use the definition. I rewrite it in exponential form. It's kind of like when we did the translation from radical form to fraction exponent form and back and forth previously. So that's it for this Firestarter.